Hi, welcome. This is a video on exponent properties, and this is at the level 4, the highly proficient level. And they've asked us to simplify the expression. It says write your answer in both exponential and radical form. And so we have to do both. There's a bit to unpack here, but let's go ahead and look at this. First, let's look at this first part here. We have a rule that says if I've got x over y, and I raise it to the power m, that's the same as x to the m over y to the m. And again, if you don't remember that, you can just take it and write a simple example. Let's say I get to 2/3 and I raised it to the fourth power. That's the same as 2/3 times 2/3 times 2/3 times 2/3. And you can see there that I'm multiplying 2 by itself 4 times, and I'm multiplying 3 by itself 4 times, and so it's 2 to the fourth over 3 to the fourth, and that just helps to explain that this rule works. And so here, if I've got, let's write it right here, 1 over m squared raised to the power 2, and then I'm going to multiply that by m to the power of 1/5. So first off, well, this is 1 squared over m squared raised to the second power, m squared raised to the second power, and that's m to the fourth. All of this is multiplied by m to the 1/5. And so here I've got, let's simplify this. 1 squared is just 1 times 1. 1 times itself 2 times, so that's 1. And m squared raised to the second power, that's m to the fourth power. Times, and then this is m to the 1/5 power, and all of that is over you've got m to the 1/5. You can divide any number by 1, so I'm going to just write that over 1. So then I've got like two fractions and I'm multiplying them. So here I go over and say, well, 1 times m to the 1/5 is m to the 1/5 power, and it's over m to the fourth power. And now I'm dividing like bases. So again, there's a rule that says if I'm dividing like bases, again, you don't remember, it doesn't matter, because you can just kind of figure out what it is. Let's say I took an example where I had 2 to the 5th power, and I divide it by 2 squared. Well, 2 to the 5th power is 2 times 2 times 2 times 2 times 2, 5 times, and 2 squared is 2 times 2. These two 2's, which are 4, and these two 2's, which are 4, and 4 divided by 4 is 1, so those just cancel in the midst of the rest of this multiplication, and I'm left with 2 multiplied by itself 3 times. And there I can see that 5 and 2 to get 3, I would have to take 2 to the 5 minus 2 power would give me 2 cubed. And so that's just the rule demonstrated, but you can also just say, hey, well, if I've got x to the m over x to the n, that's equal to x to the m over, or m minus n. So here then, I've got m to the 1/5 divided by m to the fourth. And it's always the top exponent minus the bottom exponent. So that's m minus n. So over here, let's just think about what that would look like. I'm going to go over here and use a little space. I've got 1/5 minus 4. We say, wait. I can't subtract those unless they have a common denominator. Remember that 4 is the same as 4 over 1. The common denominator between 5 and 1 would be 5. So I'm going to multiply this by 5/5. 5/5 is 1, so I'm not changing its value. I'm just changing the way it looks. So I've got then 1/5 minus 4 times 5 is 20, and 1 times 5 is 5. So I have 1/5 minus 20/5. And now that I've got that, now we're just subtracting them, have the same common denominator. I'm going to have 1 minus 20, and that would be negative 19/5. All right, so this then is equal to m to the negative 19 fifths. All right, we got another thing here we want to talk about then. What is something raised to a negative power? Recall that if I have x to the minus n, that's equal to 1 over x to the n. That the negative in the exponent just means the reciprocal. So if I've got m to the minus 19 fifths, this is equal to 1 over m to the 19 fifths. All right, now that brings us this far. Now what we can just look at this and go, hey, this right here is one of our answers, 1 over m to the 19 fifths. But we have to now convert it. We've written it in exponential form. We've written that as an exponent, rational exponent. Now we need to write it as in radical form. So we need to convert it here. And for this, we just go back and remember that if I have, let's say, x to the a over b power. You know what? I'm going to change x here. I'm going to just say let's change it back to here. I got b raised to the x over n power. That's equal to, you'll see here, that's equal to b raised, the blank root of b, that blank being n, and I like that n because it's index, and the b is then still raised to the x, so that's b to the x. So I've got b raised to the x over n power. The top number x becomes the exponent on the what's called the radicand, and then the n, the bottom number, is the index of that radical. So over here then, what have I got? 1 over the 5 here goes here, 5, and then I got m raised to the 19th power, and that is, those two are my answers in rational. I've got to take a break in writing that word. Ratio. Oh, it's ratio. Rational exponent form, and then this is in radical form, and they mean the same thing, just written in a different way.